Okay. Thanks, Ezra. Good afternoon, folks. It's our last session of the day and our last session of the virtual conference. So welcome. And Ezra's very kindly come out to do a presentation he's done before for us, I think, but it's gone down very well in previous meetings, which is a technical introduction to CICS for non-CICS people. So Ezra, take it away, please.
Thank you, Rob. Well, it's interesting to do an introduction to CICS as the last session for the conference, right? Normally, you'd probably see this in the beginning, right? This way you learn a little bit about CICS and then move forward. But of course, this is for non-CICS people. But hopefully after the presentation, you'll get an idea of what CICS is about. And this is what we're going to cover today, right? So I want to talk a little bit about what CICS is and who uses it. And then I'm going to get a little bit more complicated. So for those that, are faint of heart there, we're going to go through some technical aspects of CICS, like what is pseudo-conversational programming. I'm going to talk a little bit about the different services, application services, CICS connectivity, resource definitions. And I'm going to take this focus from the side of generally, if you're in the world of CICS, right, you'd be in one of two roles. You'd be in a system programmer role, which means you maintain the CICS systems, and you would ensure that you upgrade to the latest releases and you'd handle problems as they occur at the CICS system level. Or you'd be in the application side of the house, which means you'd be developing or upgrading code that runs inside of a CICS environment. So there's kind of two major roles if you're working deep down in the CICS world, right? And then, of course, there's a whole management infrastructure above it, but we're going to focus on what people will actually do in the world of CICS. So here we go. So what is CICS? So CICS has been around since 1969, right? June of 69. I know it came out a little bit earlier, but the official date is sometime in June of 69. So this year it turns 56 years old. And you're wondering, well, here's a product that's 56 years old. Why would anyone continue to use this product, right? Now I'm going to give you my insights into it, right? Because I've worked with it for 38 or 39 years. So I've been working with it for quite some time. And I'll kind of point out some of the insights into this product, right? So this is just the sign-on screen. If you use the default sign-on screen without security, you'll get one of these nice little CICS logos. And effectively, the biggest thing on this page that's important to see is the middle bullet down at the bottom that says 100 billion transactions a day, right? So obviously, there are people that are still using this. You can Google it, right? There's quite a number of transactions going through the world of CICS, which means there's a lot of programs behind it. And so even if you wanted to replace all the CICS systems in the world today, notice the replacement costs are estimated about $20 trillion. And probably that's, that bullet I put in a couple of years ago. So probably the number is quite a bit higher than that today. So if you wanted to just rewrite everything that ran in CICS today to run on something else, it would cost you a fortune of money to do it, and it would take a ton of time. Now, CICS itself is installed on 85% of all the IBM mainframes out there, and 450 of the top 500 companies in the world use CICS somewhere. The licenses is like every kind of CICS. CICS will run on ZOS on the mainframe, but there's a CICS that'll run on an AS400. There was even a CICS that'll run on a PC. So if you include all the little ones, maybe you get to that many licenses. You might argue that there's 30 million users, although to be honest, for example, if you were a credit card swiping application, right, where you go to a store and you swipe a credit card and they check to see that you have enough money to pay for the purchase. That's occurring constantly and lots of people do it. So do you call them a user or you don't call them a user? So if you did, that 30 million number is much smaller. 950,000 programmers is probably a little bit less today, but nonetheless, there's a huge number of programmers. And then finally, 200 billion lines of COBOL is probably an underestimate of the number that's out there. Much of this came from Google, so believe what you want. It's a busy product. Now, what is it exactly? So in order to understand why CICS came out, you have to go back to the 1960s, right? Late 1960s. If you were writing software back then, and I was very young back then, so even I wasn't writing software back then, you would have to interact directly with the machine, right? So if you wanted to write some data out to a green screen, or you wanted to print a record on a file or something, you actually had to write assembler code that interacted directly with the operating system and the low-level machine to get work done. And they realized they're not going to get many applications developed that way at a quick enough pace. So what IBM said is, we're going to build some middleware, right? Customer Information Control Systems, which is what CICS stands for. And what we're going to do is we're going to write all the underlying routines that communicate directly with ZOS and with the file systems. And today, when you look at it with DB2 and MQ and other systems. And then at the middle layer, we're going to let people write application programs. And instead of having to write file descriptors as you do within a batch COBOL program, we're just going to let you do exec CICS read, and suddenly, boom, you can read a record from a file. So now you can focus on building the application itself and not worry about the underlying infrastructure. We're going to make somebody else worry about the underlying infrastructure. You as a developer are going to write applications in COBOL, and when you need a resource, you're going to put in a simple command to access that resource, right? So that makes it really simple as a piece of middleware. It'll also let you manage the user interface, retrieve data and modify it as needed, handle all the communication for you. Sounds great. Well, we're going to see a little bit more details what that entails, but who uses CICS? So you'll find that I work with many different banks, mortgage applications, account reconciliation, payrolls, right? Credit cards are really big in terms of banking today using the world of CICS. CICS is something that will provide the information with sub-second response time. So you just imagine if you swiped your credit card at the grocery store and had to wait 3 minutes for a response, as you do on some of the web-based applications, then nobody's going to come visit your shop to buy your stuff, right? So it has to be really fast, and so that's what banks use it for. Brokerage houses, stock trading, not so much so, but certainly trade clearing is all done through CICS. Human resources through CICS as well. You have insurance companies, right? Policy administration is certainly done with very large insurance companies through the world of CICS. So it's some really big customers. It's even some smaller customers that use CICS. So how does CICS look any different than a regular COBOL program? Well, you have to understand the differences between a batch and an online program. Once you get this under your belt, it'll make things, more understandable. So if you've ever written a batch program, the idea behind batch is usually to sequentially process all the records on a file. I want to update all the records on an account balance file. Let's say, at the end of the month, we're going to pay a certain amount of interest. And so somebody has a checking account with $100 in it. We're going to add whatever interest they earn for that particular month. So what are we going to do? We're going to go from beginning to end through that file and update everybody's interest, right? That would be a batch job. So the results are transmitted after it's done, and we're not really worried about how long it takes, right? It could take a few minutes, it could take an hour. Nobody's going to really care because there isn't a user sitting there at a screen waiting for an instant response. An online application is interactive. I don't have to explain it as much because the internet came out and we all have web-based transactions. Today we have phones, right? And effectively, we expect instantaneous responses, right? So if we're going to go and look for some data, we expect to submit requests that are random and processed immediately. The results have to come very quick. The response times have to be very, very fast. And as I've mentioned, credit card applications are a good example. Now, why would you run something as big as CICS, right? It's pretty complicated to maintain. You need a set of system programmers to maintain the systems. You need application programmers to actually develop the applications. Well, if you're going to use CICS, then you have to be a pretty large business or expect a large transaction volume, right? You want a multi-user system so that you let users interact directly with the system itself. So simultaneous access to data can be quite confusing because you have to make sure that you have the integrity and the security today to be able to support that. And when I say security, right, you want to make sure that bad actors aren't accessing your applications. Integrity control means if I transfer $100 from my checking to the savings account, you'd notice that when people write the applications, they always do the subtraction first, right? Because something goes wrong, you lost the money, right? The bank hasn't lost the money, right? So they'll take the $300 out of checking and then they'll put the $300 in savings. The idea behind integrity in the world of CICS is a transaction will complete successfully or it will not have run at all. And therefore, if you say, take it out of checking and put it in savings, and we took it out of checking and a failure occurs, we expect somebody to put the money back into your checking account. And that's the idea behind integrity within the world of CICS. Now, just some stuff to understand, acronyms, right? So everything in CICS is a transaction, but it's kind of a little bit of a lie, right? We start with a 4-character TRAN ID, even if we don't type it on a green screen anymore. Behind the scenes, everything is triggered in CICS by a 4-character TRAN ID, and we tend to refer to a business transaction like account or loan by its 4-character TRAN ID. And then what you might see something is like on the bottom right-hand side where a user will type in a 4-character TRAN ID, hit enter, he's going to get a screen, he's going to fill out some data on the screen, he's going to hit enter again, he's going to get the results of where the part is located in this particular example, right? And you're going to say, well, that's a transaction. Well, sort of. That's a business transaction. But what is it really? So everything in CICS is broken up into these things called tasks. And effectively, when you're dealing with a 3270, every time you hit enter and get a response back, that's pretty much a task, right? Tasks can involve multiple programs, right? So it doesn't mean you're only running a single program. Programs could link to one another. The task is what we consider to be the logical unit of work, and we're going to explain why we need it this way. So to go through a business transaction, you might go from screen to screen to screen to screen and go through 15 screens. Next thing you know, you actually moved some money from one place to another. Effectively, from the CICS perspective, we treat it as 15 individual tasks. And it's interesting because when we measure how many tasks, you remember the first page, I said we run 100 billion transactions a day. Well, it's really 100 billion tasks per day because that's the only thing we can measure. We don't know how many tasks make up the business transaction. Now, CICS itself can run the work concurrently if you're running in a thread-safe environment and you have enough CPU. But in the old days, he was really just a task switching system. But he switched between these tasks so quickly that it looked like 100 users were actively running in the system at the same time. So he basically gave brief amount of CPU to everybody in a short period of time, and everybody had the impression that they were running simultaneously. Now, in order to support this, what IBM did was they invented this concept of pseudo-conversational versus conversational. Conversational is easy to understand, right? You're on a web page, whatever it might be, and you type in some data, you hit enter, you get a screen back, and you're staring at that screen for 5 minutes. What it basically says, you're in a conversation, and effectively, you're holding up resources at that given time, right? Waiting for you to do something else. Maybe it's to type in more data. Maybe it's to hit a button on the browser. If it's a 3270, maybe it's to hit the enter key, right? And effectively, a conversational transaction means you're holding resources and you're holding a slot within CICS to run. So IBM says this will never work, right? Because regions have a limited amount of storage. So if you want to be able to run a number of people at the exact same time, we have to find a way to get around this. And what they built was pseudo-conversational programming. Pseudo-conversational programming looks the same as a conversational task. In fact, when you're looking at a screen or a browser, you can't tell if the application is conversational or pseudo-conversational. But the way it works is like this. So Conversational task says, what we're going to do is we'll type in a TRAN ID, hit enter, we get a screen. And while you're waiting to type data in a screen and hit enter, the system's waiting for you. It's a single task. So instead of the business transaction being made up of 15 tasks, it's one task. Now, what's the problem with this? Well, you decide you're going to start this transaction, and maybe it's 15 screens. You get to screen 3 and you get a little hungry, right? So you decide, I'm going to go down to the cafeteria, buy myself a sandwich. Then you meet Bob on the way and you're schmoozing with Bob a little bit. And next thing you know, an hour goes by. And in an hour, you've been holding those resources in CICS, possibly even locking out records, right? Because remember, for integrity, we can only ensure one person accesses a piece of data at a given time, right? And they realized that ain't never going to work. So what they did was they said, well, we're going to do this thing called pseudo-conversational programming. That says that every time we're going to respond to the user, we're going to end the task. So instead of doing a receive and waiting for a response, we're going to do an exec CICS return. Now, at the outset, just looking at that, this sounds crazy. Every time the user hits enter, we're going to start the whole process over again. Well, no. What we're going to do is we're going to save off some data somewhere to let you know the state of the task. And that's how the web works today as well, right? We're going to put the state of the task somewhere. And when the user hits enter or any function key to reignite the application, we're actually going to start from scratch. But the program's going to start out and say, oh, excuse me, have I been here before? Oh, yes, you are. You're in the third pseudo conversation, and this is the screen you should be looking at, and this is the data that the user should have passed me, and you're going to get to the next sequential instruction of where you left off before. Okay. So that says that instead of doing the same process of 3 screens with one task, you might have 4. Every time you hit enter, you get a new screen. Now, it means the programming is a little bit more complicated because before you end a task, you have to save off just enough data to remember how to get back to where you left off. So you have to designate what's going to come next. And once IBM built this, everybody started writing programs in a pseudo-conversational fashion, and that's the way most applications run in CICS today. Now, in the old days, we'd build one program. Sounded like a great idea. Problem is that we realized different things at the presentation layer changed, different things at the data layer changed. At the presentation layer, we started with a green screen 3270. Now we can do things on the web. Today, I can send JSON data back down to an analytics engine from CICS if I want to. So I never know what the presentation layer will look like. Let somebody else build that, right? Because green screen 3270 is not really the way to go moving forward, right? So whatever you want to do application-wise, build the presentation layer separately than the business layer. And that's what we did. We separated the presentation and business logic so that we could invoke the business logic directly in CICS. And you might hear of things like web services or ZOS Connect, and that's really what they're communicating with. Some customers have gone to the trouble of separating out the data layer or data services. One minute you're using DB2, next minute you're using Oracle or some other database, MySQL, right? And so if you separated out those programs, you could choose and replace that layer whenever you wanted to. So the core of most business applications today, written in COBOL, PL1, C, Java, right? The business logic itself is what we tend to run in CICS. Now, when CICS was delivered, they supplied it with a bunch of application services, right? They were transactions that came with the product that made it easier for you to do things like run diagnostics against your CICS transaction. Wouldn't it be nice is if every time you issued a CICS command, you could stop before and after the command and check to see if you were passing the right data in and the results were coming back properly. So you can use CEDF or CEDX for that. These are built-in transactions, come with CICS. They even have a debug tool that's free that comes with CICS. Now, if you wanted to test out a CICS command, you can use the CECI, which stands for CICS Command Interpreter, right? You can try any command before you write it into the program so you get the syntax properly, right? In fact, the commands actually do work. Some system programmers will use those commands to fix a file, right? Because they actually execute. Aside for just showing you the syntax, you can execute the commands as well. So there's a bunch of built-in functions, right, that come with CICS. And those are the CICS services. And then there are the CICS API. You can run the CICS API, and I'm going to show you what commands look like in just a second. You can run the CICS API almost regardless of the programming language you're using. We support Assembler, COBOL, C, C++, PL1, Java, Rex, right? And so you can write the programs in different languages, and you can run them in CICS. Now, what does a CICS program look like that's different from a batch program? So here's a COBOL program on the right-hand side. And what makes it a CICS program is a sprinkling of CICS commands. All the CICS commands start with exec, short for execute, exec, CICS, a function followed by an argument. I'll give you an example in just a second, right? So this command itself is what programmers would put inside of their COBOL programs. Now, an example would be, I want to read a record from a file. So I would do an exec CICS read. Well, I have to provide the key of the record that I want. That's called an RID option, right? And I'd give him a working storage field where I'd place the record ID in, and suddenly he'd read the record. But where would it go? Well, I could either set a pointer to it, or I can have it put inside of a working storage section within my program, right? So what a CICS application programmer had to learn were CICS commands, right? And there's a number of them. And today, if you're supporting a CICS application, you're not doing as much new development, you might come across programs and you need to understand the commands. They're all documented. Today, I don't even use the documentation. I Google it, right? And next thing you know, it throws me in the IBM documentation. Now, what made a CICS program slightly special in the old days is if you tried to compile a CICS program with a COBOL compiler in the past, it would choke and die because COBOL never understood what CICS was. So we would have to run a translation step. You can see what the translation step did on the right-hand side. It would comment out the CICS command and basically put in a call to a stub, which I'm going to show you in just a second, right? However, today, we've integrated the translator into the COBOL compiler, so you don't actually have to run a translation step separately. The COBOL compiler can actually do the translation for you. Now, there are some nuances between the two. So if you end up working in the application development side of a CICS shop, you might find that they're still using a separate translation step followed by a compile step. Some are using the integrated translator. Now, on the left-hand side, you can see we just feed the COBOL source into a COBOL compiler, or we do a translation and then put it in a COBOL compiler. That's just going to comment out the CICS command. That is a real CICS command. You can see exec CICS read. We have to tell them the file you want to read, the key of the record, where do you want to put the data once you get it, and then the update flag lets us know that we intend to update the record, right? So this will usually be followed by a rewrite command, right? Now, you'll also notice there's a resp value in here, and so we can test that field to see if the command was successful or unsuccessful. What would be an unsuccessful command? Well, I get a not found on the record, correct? Now, we would take that, compile it, we would create an object module, and then notice we talk about link editing a CICS stub. The reason is notice that we have a call command here on the right-hand side. When we commented out the CICS command, right, we have to put in the stub that we're going to call when we want to actually get to this piece of code. Now, on this page, what we're actually showing you is that when the program is executed, at the time we do the call, that will call into the CICS stub. DFHELII is the most current stub, but you could be using an older one. That knows how to find a program called DFHEIP. Everything in CICS starts with DFH, dollars for hardware or dumb, fat, and happy. We have lots of names for what DFH means, but it's just 3 letters. And then EIP is the exec interface program. He knows how to find the CICS component that's going to do the work for you, right? And once he's done the work, he's going to give control back to EIP, which will give control to the next sequential instruction inside of your application program. Now, I mentioned, or I should have mentioned on this page, there's something called the EIB. The exec interface block is how you fill out data to communicate to and from CICS, right? So you'll notice that if you wanted to find out the terminal ID you were running under, you could check EIB term ID. If you wanted to know your own task name, you say, what is the EIB task name, right? So these are just things you could look at. This control block ran out of space probably 30 years ago. So there are some exec CICS inquire commands that IBM always adds to that you can pull the data from. But originally they used a control block to hold these values. You'll also notice at the bottom of the page, that's where the response and the RESP2 value goes to. So there's an overall response, and then there's a RESP2 value that gives you more information as to why it succeeded or failed. Now, in order to support a pseudo-conversational environment, we need a way of saving off and passing data. In the old days, everything used a communication area or a COM area, as we called it, and it was basically a storage area that you would save off between your pseudo conversations so that you knew that if there's a COM area waiting for you, this ain't the first time through the program, and therefore you could look in that data area to see where you left off during the last conversation. But it was only one area. It was an overloaded copybook, and it was limited to 32K. So IBM about, 15 or 20 years ago came out with the concept of channels and containers. It's less associated with storage and more name related. You build something called a channel, which is a 16-character name. And in the channel, you can have these things called containers, which are different data areas, which are not limited to 32K. That you can store data in and pass not only to yourself during a pseudo conversation, but you can pass it between programs as you call those programs. Now, the advantage of this is you could literally have more or less data. When you were stuck with a COM area, you basically had empty spaces that you were passing around to programs because you needed to make sure the darn thing was big enough to hold everything you could imagine within the application. So a lot of customers converted from COM area to channels and containers, but either way, the job is to pass data between programs or pass data to yourself between pseudo conversations. Now, the biggest problem with CICS in the early days was the fact that address spaces only used 3 bytes for addressing. And if you do the math, right, 24 bits only gives you enough space for 16 megabytes. So CICS was tiny. So we weren't able to run everything in a single CICS region. So what we had to do was break it out into multiple CICS regions and basically ship workload between these different regions to get the processing done. Then IBM turned around and said, oh, guess what? We're going to give you much more storage, right? We're going to give you 2 gig and you'll never run out, right? 31-bit addressing. Needless to say, a lot of customers ran out there as well. And so now today we have the bar, right? We have 64-bit addressing. COBOL doesn't use it yet, but certainly 64-bit assembler exists. So effectively what they did was they built workload that went to different regions. Sometimes the regions, as in this case, were clones of one another. And then what you're seeing on this page is the different ways to connect up CICS regions. They called it MRO, ISC, batch could communicate with CICS via EXCI or ECI. We even have TCP/IP communication. So you're going to see a lot of different ways that CICS regions or batch are connected to CICS. And this is just some explanation for that. You can read that separately. So that was all about what a application programmer would have to do to get a program running. So why is it we have system programmers, right? Do we need them? What do they do, right? Well, the answer is nothing in CICS runs unless the system programmer defines that resource to a CICS region. You want to run a CICS program in a CICS environment and it is not defined, you can stand on your head, jump up and down. You ain't running no CICS program, right? You need a sysprog to define that program. You need him to structure where the load libraries exist so the program can be loaded into a CICS world and run, right? If you want to access a file, it better be defined to CICS, otherwise you can't do it. So the CICS sysprog is responsible for defining the resources available in a particular CICS region. Over on the right-hand side here, you can see he's also responsible for doing things like tracing and monitoring and finding problems and letting you, the application programmer, know there's something wrong with your application. You got to go and fix it, right? And we log a bunch of stuff as well. So this is just a list of resources. Now, the resources are just definition types. You can imagine a tran ID is 4 characters, but it has to indicate the initial program it needs to run. So the system programmer needs these details, and he sets these attributes inside the resource definition itself. That resource definition lives on a file called the CICS system definition file, and he can choose to install it in a live system or not install it in a live system, right? And he can make that choice on a daily basis, or he can literally run with whatever ran the night before. So there's a lot of decisions that a system programmer has to make. As a matter of fact, how to define the resource over the years has changed many, many times. We used to have macro level tables. You see at the bottom of the page, we talk about macro definitions. So every time we needed a table change, we'd have to assemble it using a macro level table. And then in order to get it into CICS, we had to recycle the CICS region, which would have caused an outage, right? If you don't have high availability, for example, you'd have to bring a region down and bring it back up to get a macro level table change. So IBM says, oh, heck with that. We're going to build this resource definition online. We're in the modern world, and we're going to be able to dynamically install resources inside of a CICS system. And in fact, we're going to provide the tran IDs that a system programmer will use to define them. So CEDA to do definitions and installations in CICS. And then we're going to give you some other transactions that will have different levels of security, whether you can do defines or installs, whether you can actually look at the resource definitions. And then as a matter of fact, we're going to give you a batch utility so that you can do mass updates instead of going through a 3270 screen and typing everything in and hitting enter. You know, imagine defining 100 programs into a CICS environment. It could take you a long time, right? And nobody liked to do that. Or auto install. Sometimes we can automatically figure out, right? Oh, some guy just tried to run a program called Prog A. Let's go see if there's one out in the library. Oh, there's one out there. You know, I can tell it's a COBOL program. I'm going to give it a default set of attributes, and I'm going to automatically install it in the system. Now, chances are they probably wouldn't want to do that in a production environment, but certainly why not do it in a development environment, right? So many different ways to define resources. Here's just a picture of the screen. If you do a C to define, and this was back at CICS version 5.4, obviously every release of CICS has a different set of resources that you can define. You can see I can define things like files. I can define things like transactions or TCP/IP service definitions to actually communicate over TCP/IP. So these are just a list of some of the resources that could be defined at that time. This is also to show you that, you know, if you wanted to, you could use some of the built-in facilities to web enable it, right? So there's me using a web enabled screen I built in the past to actually define resources to a CICS system using the 3270 bridge. But on the right-hand side, you can see I'm inquiring on a transaction called Trek, and you'll notice all these attributes. So before you think that the system programmer's job is simply to define these things, he's got to understand what all this stuff means, right? All these attributes mean something and provide additional support for other stuff. So for example, whether or not it's tran classed, right? Whether or not it's running in isolation, right? Are we using tran ISO in our environment? So the system programmer learns how to manage the environment, build the resources that he needs, ensure that the attributes are set properly. Now, over the years, we've developed 100 different ways to connect to a CICS environment. 3270 green screen is built in, but today you can even get any batch job communicating with CICS, Java applications, whether you're running inside or outside of CICS. You can use things like CICS Web Services, the 3270 Bridge, WebSphere, Socket application, ZOS Connect. Everybody wants to talk to CICS. Why? Because the applications, the business functions run in CICS. And so you can see in our environments, depending on where we are, who we're working with, what the programmers on the middleware processing that they've done. Are they coming in from a PC? Are they running some software product on a middle tier processor on a server out in server land? Has some magic way to do a connection to CICS? They're going to figure out how to do it. And as a system programmer, you got to figure out how to make that connection work. Now, I always like to throw up this page because when CICS came out with CICS Web Services, I built all my applications so that I can connect to CICS from a browser. Yeah. So this was a lightweight application that had a 3270 based front version and a CICS based version. And sadly, the screen in the middle was from the old what was it, Flash presentation. So you had Martians watching TV and the CICS on the web was flashing by. And then, of course, Flash became a big no-no, right? So I just show you a picture of it here. But you can deliver anything from CICS because guess what? It's the browser that determines how this thing is displayed, not CICS. CICS can deliver a blob of data. He don't care what it is. And he'll tell the browser he's getting a PDF, JSON, doesn't matter what it is. And that client is supposed to understand how to take that data and process it. So I have delivered some amazing stuff in the world of CICS. Now, CICS support web services. CICS can be a web service requester or a provider. Relatively simple. IBM's giving you utilities to consume or build WSDL definitions, right? And CICS support web services. We can actually use RESTful APIs into CICS today, so we can actually have JSON coming in and out of CICS as well, right? We even support services-oriented architecture where we go through and a service requester will send us some ridiculous message, most of which we won't understand. And then we go through these message handlers that pull out the pieces we don't care about. And eventually the CICS application program gets a bunch of data that he understands that you've carved out through those message handlers. And then when you send the response back out, you can put all the stuff back around it through these message handlers. And so the client has no idea he's talking to CICS. CICS has no idea that the client is some, RESTful API request. So IBM built all this stuff. You can use web services standards such as WS Security, WS Trust. Most of this stuff is all fully supported within the world of CICS. Now, some around the new stuff, CICS supports event processing. Because it's so hard to get resources to modify applications within a CICS environment. Today, we can actually detect events that are going on and hopefully build new processes in CICS using new languages like Java based on events that trigger. Those events could be business events, they could be system events, like, oh, if somebody reads this particular record on a file, I want to know about it. Boom, it'll trigger an event that will run in a JVM running in CICS with a Java application. Life is good. And so based on the event processing, we can pick up stuff from older applications without having to go into the source code to make changes. And IBM provides an event builder or processing environment using the CICS Explorer, right? Okay. So Here's an example of the CICS Explorer plugin. So you can see if we're set up with a CICSplex, we can see all our regions on the left-hand side. We can manage the resources in a CICS environment across multiple CICS systems. You've seen some presentations on CPSM. So you build a CICSplex environment. You can structure, maintain, and manage a full CICS system from one location, right? Then my favorite. So this is something I did recently. Hopefully you can see the screen. It's a little bit small, but this was me working with Joe Winchester and a bunch of people on building an interface for VS Code that would allow a developer who can develop COBOL programs in VS Code to get them compiled. And then on the left-hand side of the page, you can see there's an extension for CICS that will actually allow you to go in and new copy the program and make changes to a CICS environment, all from VS Code, maybe never logging on to a 3270, because maybe the application runs from the web. You don't even need a 3270, right? And so it's designed pretty nicely. They keep it up to date. And interestingly enough, the people who actually built this for us were students that knew VS Code and didn't know much about CICS, right? But there is a command line interface that allows you to send requests into CICS and get stuff done for you. Yeah. Now, there are plenty of tools available in the CICS world. Some of them I support. For example, IBM OmegaMon for CICS is a product that my company writes for IBM, and we support and provide services for in the CICS world. There are other products, things like vSAM Recovery, CICS Performance Analyzer, another tool I support, right? And so there are a bunch of tools that you can purchase. They're, add-ons to the environment that help you manage process CICS-based workload. Now, what I wanted to show you toward the end of this presentation, and I know we're running out of time, but don't worry, this is exactly where I want to be. And this is to show you that every 1 year to 2 year, and it's usually around the 18-month mark, IBM comes out with a new version of CICS. And what I wanted to do is show you from CICS version 5.5, which is still supported for a little bit of time now, all the way up to 6.2, right? And I don't think I have 6.2 in here yet, to show you what IBM's been doing with the CICS product, just to point out what they've added to CICS to make it current. So even though the product is 55 years old, it doesn't mean it's old, right? I would argue that Java is what, 25 years old? How old is Windows, for God's sake, right? So when you say something is old, it doesn't mean it's not up to date. It just means it came out a long time ago, and it probably has a lot of good value today. So at 5.5, we were supporting Java EE version 7. We added Liberty JVM enhancements. We added security through the Angel process, right? The CICS Explorer was given more capability to improve the user experience. We added the GraphQL API, which means if you have the CICS Explorer and you connect up through the web user interface, it would run under a CICS JVM. So all the customers that say, oh, we don't run Java in CICS, yes, you do. If you have a CICSplex and a WUI, you're running Java whether you want to or not, because that's how IBM implemented it. At 5.6, they upgraded the version of Java. And in fact, now it's Jakarta EE version 8, right? Because we moved the licensing from directly through Java through Jakarta, right? You can see an enhanced CICS API. You can see support for Node.js, right? A lot of people know how to use Node.js today, so that's pretty good. And then some other enhancements like support for 32K COM areas on distributed links. Some of these were fixing problems from the past. From 5.6, we went down to 6.1. 6.1, again, Jakarta version 9.1 with Eclipse Micro Profile version 5. Support for ATTLS version 1.3, which is the latest and greatest. They built health checker for CICS, so that when the CICS region comes up, he tells you how healthy the environment is, right? And so they've been adding and making more improvements in the CICS world from release to release. So I didn't put in a 6.2 picture, and there will be a new release of CICS coming out in the near future, probably very near future. So what I wanted to point out was CICS is ideal for any sort of transactional environment. It ain't going away anytime soon. In fact, we'd love to see more and more resources join the world of CICS. And again, it's a highly available system, easy to maintain, and highly scalable, right? I added at the very end of this a bunch of reading hyperlinks, right? I believe they're all current. I tested them recently, but you never know when one of these links will break, right? But this will give you some more about the product information in the CICS Explorer. And then here, if you wanted to read, there's a whole slew of red books out there that are usually easier to read than manuals. It will take you through things like implementing web services in CICS, if that's something you're interested in doing. So you can take a little bit of read through the red books. So here's my contact information. If you ever have any questions, feel free to reach out. Always happy to help system or application programmers. I'm one of those weird people that straddle both sides of the fence, okay? So if you ever have any questions, please feel free to reach out, and please fill out a session evaluation when you get the time. So any questions? Let me stop sharing. See if
There's no questions in the chat, Ezra.
Okay.
Thank you so much for doing that.
No problem.
This is our last session, so no more until the in-person conference for GS UK, and I'll plug that. It's the first week in November at Whittlebury Park again. So if you've got travel budget, please encourage you to try and speak to your managers and come along to that one. And yeah, GSE, the door's open. If anyone's got any queries or want to know anything, all the contact details are on the website for the CICS working group. We'd be more than happy to help any customers with any questions at all. And
Perfect.
without further ado, Ezra, hopefully I'll see you in the near future. But thank you once again.
Yeah, I'll see you at GSE UK. I'm already booked to come. So
absolutely marvelous. And so good luck on over the pond. Yep. And cheerio, everyone. Thank you very much for your time. And please don't hesitate to fill in the feedback forms, QR code on the presentation, or the links are direct clicks on the agenda on the website, and you can do it directly on the website if you want to. Thanks for your time, everyone. Bye-bye.
Thank you. Bye.
Bye.